Hello, welcome to our chemistry class. See students, we are studying atomic structure. So far, we have been discussing so many theories like Dalton atomic theory, Thomson atomic model, Rutherford atomic model. Thereafter, we have discussed Bohr atomic model. Today, we are going to discuss advanced theories concerned to wave mechanics, particularly that is de Broglie wave equation and followed by Heisenberg uncertainty principle. See here students, in last class we studied Bohr atomic postulates and also we have seen hydrogen spectrum. But there Bohr theory failed to explain some of the properties of electron in an atom. Particularly, we already discussed in last class, particularly the main drawbacks of Bohr atomic model is this Bohr atomic model explanation holds good to only one electron atoms. That means atoms whose contain single electron like hydrogen atom and helium plus 1, lithium plus 2 ions. That means it could not explain the behavior of electron in multi-electron atoms. That is one of the main failure. Then second one, it failed to explain the Zeeman effect and Stark effect. And also this theory could not give complete distribution of electrons around the nucleus in an atom. Like that, Bohr committed some of the mistakes. To overcome these defects, the new theories come into the light, particularly during the period of 1925 to 1930. 1925 to 1930. Now, I would like to explain the very important and significant theory, that is de Broglie wave equation. De Broglie wave theory or wave equation. Should you write down students? De Broglie's wave equation. De Broglie wave equation. See here student, so far we have been studying different theories. All these theories, Dalton's, Thomson, Rutherford and Bohr, Sommerfeld, all these scientists, they suggested electron is a having particle behavior. That means all these theory considered an electron is a particle. But actually that is not right, because electron or matter or electron or light energy or radiation, whatever it may be, that can have both the characters. For example, matter can have dual nature, particle nature, as well as wave nature. In the same way, whatever we are studying, the subatomic particles present in inner core of an atom, like electron, proton, and neutron, those charged microparticles can have both particle as well as wave nature. After examining, Debroglies had given one equation, mathematical equation. What is that? Lambda is equal to h by mb. Lambda is equal to h by mb. Of course, students, is very easy to please write down. See, electron can have dual nature. That means it is having particle and as well as particle and wave nature, like matter. So he had given following wave expression for electron or moving electron around the nucleus in atom. So what he had given, lambda is equal to h by mb. This relation he proposed by Debroglies scientist. See here, student. Here h means Planck's constant. Already we know this. M is equal to mass of the electron, V is equal to velocity of the electron. So whenever the mass of electron which is associated with velocity, then that is called momentum. That means here ORR, lambda is equal to h by p. Anyone is right, you know this. So where h is equal to Planck's constant, you remember this value is a fixed value, remember, and it is useful while doing the problems. So Planck's constant, that value is 6.625 into 10 power minus 27 erg into second. If you take the value in joules, then that is minus 34 joule into second. This is the Planck's constant. So m is equal to mass of electron. It is very small one, actually negligible mass. Electron can have negligible mass. So mass of electron, I think it is equal to 9.1 into 10 power minus 31 kg. If you want to express this value in grams, minus 34 grams. Students, you have to copy down all this. Then V is equal to velocity of an electron. So which is equal to light velocity. So how much velocity it is having? 3 into 10 power 8 meter per second. If you want to express this speed in centimeter, 3 into 10 power 10 centimeter per second. You remember all those values, which will be helpful to do the problems further. See students, now I want to solve this relation. How he had how he had proposed de Broglie given a equation, how that relation came. I want to solve this relation. See here. So students, so here deducing the or solve solve the relation, solve the de Broglie's wave relation, wave equation or wave equation as the following. See, scientist Einstein is a wonderful scientist in the 20th century. He had given a famous relation in between energy and mass. What is that? E is equal to mc square. This is Einstein equation. What is this Einstein equation? Particularly, it represents particle nature of electron. This equation represents particle nature of electrons. Okay, you call that is first equation. So E is equal to mc square is a famous relation and equation which was given by famous scientist Einstein. That is equal to E is equal to mc square. That means energy and mass both are interrelated variables with the difference of c square. Where m is equal to, when we apply this equation to our electrons, m is equal to mass of the electron, c is equal to velocity of the electron. You know this. So particularly that equation represents the particle behavior of electron. So one thing you remember, when electron is high in speed, that can have particle nature. Okay, so one more relation we have seen in Bohr. What is that? As per Planck's, E is equal to h mu. This is called Planck's equation. Already we studied Planck's equation. Particularly this Planck's equation represents the wave nature of electrons. Okay, you call this is equation 2. So both are energy expressions for electron. Then equation 1 is equal to 2. Everyone knows the simple one, because in both the relation the common term is energy, E. That's why equation 1 is equal to 2. See here, mc square is equal to h mu. Already we studied mu is equal to, frequency is equal to c by lambda. So frequency and wavelength, those terms are interrelated with inversely proportional. Mu is equal to c by lambda. This is the frequency of electron, this is wavelength of an electron. Because we are studying microscope particle, subatomic particle, electrons particularly in atomic structure. Okay, then see, mc square is equal to h into mu is equal to c by lambda, isn't it? So here you can cancel same terms, c cancel. Okay, then we get the relation here, mc is equal to h by lambda. Okay, lambda is equal to h by mc. So here one thing you remember, c means velocity of light or electron, that is equal to v. So finally we got the relation lambda is equal to h by mv. This is called, what is this? De Broglie wave equation. Isn't it, students? Very easy, but you have to practice 2-3 times you get perfection. Okay student, please copy down. You should maintain running notes for your clear understanding. Okay, with this we completed Debroglies wave equation. So from this you try to understand here what happens. The wavelength of frequency, which is you know h is a Planck's constant, no? Here wavelength of frequency is inversely proportional to mass. From this what we can understand, wavelength of an electron which is inversely proportional to mass of the electron. In the same way, wavelength is inversely proportional to velocity of electrons. You remember these two relations. From this we come to conclusion that the nature of electron, how it behaves in an atom which is moving around the nucleus. So that means whenever the charged body revolving around the nucleus or whatever it may be is maybe an electron, microparticle, or maybe sometimes it is a macroparticle. For example, the revolving micro one can have low mass, then that can have more wavelength. Okay, in the same way velocity of the electron is more in nature, then that can have low wavelength. So these are the very important relations you write down, and I give you theory notes for this. See here, the wavelength increases for a microparticles like electron, proton, etc. The wavelength increases for a microparticles like electron, proton when they have less or lower mass, less mass, and very minimum velocity, minimum speed, that is nothing but minimum speed, and vice versa. See student, here you try to understand, let me explain in Telugu. ఏదైనా ఒక చార్జ్డ్ బాడీకి మాస్ అనేటటువంటిది చాలా తక్కువ ఉంటే, ఇప్పుడు ఎలక్ట్రాన్ మాస్ చాలా తక్కువ, ప్రోటాన్ మాస్ చాలా తక్కువ ఉంటుంది. మాస్ తక్కువ ఉన్నటువంటి పార్టికల్స్కు స్పీడ్ కూడా తక్కువ ఉంటే దానికి వేవ్ లెంత్ ఎక్కువ ఉంటుంది. వేవ్ లెంత్ ఎక్కువ ఉంటుంది అంటే ఇట్ లుక్స్ లైక్ ఏ వేవ్, దట్ మీన్స్ ఇట్ కెన్ బిహేవ్ లైక్ వేవ్స్, దట్ మీన్స్ ఇట్ కెన్ మూవ్ ఇట్ ఈజ్ ఇన్ ద ఫార్మ్ ఆఫ్ వేవ్స్. అంటే అదేమవుతుంది, ఆ సూక్ష్మమైన కణానికి మాస్ తక్కువ ఉంటుంది, ద్రవ్యరాశి తక్కువ ఉంటుంది, అదేవిధంగా స్పీడ్ తక్కువైనప్పుడు అది ఏ స్వభావాన్ని చూపిస్తుంది, వేవ్ స్వభావాన్ని, తరంగ స్వభావాన్ని చూపిస్తుంది. అంటే ఆ పార్టికల్ ఎలా మూవ్ అవుతుంది అని అంటే, ఫర్ ఎగ్జాంపుల్ లెట్ యూ టేక్ ఎలక్ట్రాన్ విచ్ ఈస్ ట్రావెలింగ్ అబౌట్ ఇట్స్ యాక్సిస్. Here what happens, it can have low mass and low speed, then it behaves like this. That means it propagate making wave. Okay, it can propagate one place to other place, move from one place to other place, which is in the form of waves. Okay, and vice versa. For example, ఏదైతే ఒక మైక్రో పార్టికల్ కాకుండా మ్యాక్రో పార్టికల్ తీసుకుంటే, పెద్ద వస్తువు కాక తీసుకుంటే, క్రికెట్ బంతి లాంటివి కాక తీసుకుంటే, వాటి మాస్ పెరిగి తర్వాత వాటి స్పీడ్ కూడా పెరిగింది అంటే స్పీడ్ కానీ మాస్ కానీ పెరిగితే దానికి ఏమవుతుంది అంటే వేవ్ నేచర్ అనేది డిజపియర్ అయ్యి పార్టికల్ నేచర్ కనపడదు. ఫర్ ఎగ్జాంపుల్, ఒక బాల్ని మనం స్పీడ్గా ఇసిరేస్తున్నప్పుడు స్ట్రైట్గా వెళ్ళిపోతుంది. సో ఇట్ రిప్రజెంట్స్ వేవ్ నేచర్ వెన్ ఇట్ ఈస్ స్లో అండ్ హ్యావింగ్ లో మాస్. When it is high mass and with high speed, then it shows it represents what? Particle nature. If this is cricket ball, let you feel it is cricket ball, when it move from one place to other place with high mass and high speed, then it can behave as particle nature. So microparticles like electron, they have lower mass and speed will be less, then they can behave. For example, you take this is electron, then it behaves, what is that? Wave nature. Wave nature, because it is electron. I already told you remember the difference, the distance between successive crusts, difference between two successive crusts, that is what this is, wavelength. This is called the distance of two successive crusts. This is called crust, crust is called, what is that? Wavelength of that particular particle. Okay. From Debroglies concept, particularly, he ruled out the Bohr concept. Actually, in Bohr theory, Niels Bohr considered electron as a particle, but that is not correct. That is not. So Debroglies theory, Debroglies wave equation ruled out Bohr concept. What he thought at that time. On that time, he thought electron is a particle, but that is not right. That is disproved by Debroglies concept. See, as per Bohr, see students, as per Bohr theory, in his postulates he given angular momentum of the electron MBR is equal to n into h by 2 pi. This is Bohr equation. This is called what? Bohr equation. In his theory, what he said, the angular momentum of an electron, which is equal to integral multiples of h by 2 pi, already we discussed and we have seen this equation in his postulates. Okay, that means what he said, see, in an atom, the center part is nucleus, this. So the charged microparticle electron, which is moving around the nucleus in a stationary orbit. This is called what? Orbit. No doubt it is stationary orbit. What do you mean by stationary orbit? That means the electron which is revolving around the nucleus in a stationary orbit means that particular electron don't want gain and lose the energy. That means energy should be quantized, energy fixed throughout that orbit. That's why it is called what? Stationary orbit. So that we can able to predict. What is that position and velocity of the electron around the nucleus as per Bohr's theory. But the modern theories, particularly wave mechanics and quantum mechanics, decided and justified it is not possible to calculate the position of electron and velocity of electron around the nucleus. Why? Because electron not only a particle, it can have dual character. In addition to particle nature, it can have what? Wave nature. That means around the nucleus, electron moving like this. That means it looks like wave. So we cannot measure the fixed radius from electron to nucleus. That's why we cannot able to, it is impossible to determine the exact position, and also not possible to calculate the velocity of the electron, because it behaves what? It can have wave nature. So this is the failure of Bohr theory. See here, Bohr proposed, he had given one relation, that is MBR is equal to n into h by 2 pi. This is angular momentum of electron. So here I bring 2 pi this side. 2 pi r is equal to 2 pi r is equal to n into h by mb. N into h by mb. Just now we studied, no, what is the relation of h by mb? H by mb is nothing but what? Debroglies wave equation. That means I write 2 pi r is equal to n into h by mb means lambda. That means you know what is this 2 pi r? 2 pi r means circumference of circle. తెలుగులో ఏమంటాం బాబు? వృత్త పరిధి. సర్కంఫరెన్స్ ఆఫ్ సర్కిల్. circumference of circle of an electron which is equal to integral multiples of wavelength of electron. Wavelength of an electron. So this is the relation, you know. So circumference of a circle of an electron which is equal to its wavelength. That means here what happens? Bohr suggested electron behave like a particle, but as per his equation, what we have here, the circumference of circle which is directly proportional to wavelength of an electron. That means here circumference of circle which is directly proportional to wavelength of electron. So wavelength of electron means wavelength represents the what nature of electron? Wave nature of electron. Okay, wave nature of electron. ఈ వేవ్ నేచర్ అనేటటువంటి విషయాన్ని బోర్ అనేటటువంటి వాడు చెప్పలే. పైగా ఆయన ఈక్వేషన్లోనే ఇంటర్నల్గా ఏముంది? వేవ్ క్యారెక్టర్ ఉంది. బోర్ థియరీ సజెస్ట్ చేయలేకపోయింది. ఇది ఒక ఫెయిల్యూర్. దాన్ని ఓవర్కమ్ చేసినటువంటిది ఏది? డీబ్రూయి. కాబట్టి ఈ రిలేషన్ ద్వారా కూడా, బోర్ ఇచ్చిన రిలేషన్ ద్వారా కూడా చూస్తే ఎలక్ట్రాన్ అనేటటువంటి ఒక మైక్రో పార్టికల్కి పార్టికల్ నేచర్తో పాటు ఏమవుతుంది? వేవ్ నేచర్ కూడా ఉంటుంది అనే విషయం మనకు నిర్ధారణ జరిగింది. ఓకే, దిస్ ఇస్ ద కంప్లీట్ స్టోరీ అబౌట్ డీబ్రూయి వేవ్ ఈక్వేషన్. ఇక్కడ మీరు ఇంకో విషయం కూడా గమనించాలి పిల్లలు. మనకు అన్ని వాల్యూస్ ఇచ్చి, అంటే లాంబ్డా ఈజ్ ఈక్వల్ టు హెచ్ బై ఎంబీలో లాంబ్డా ఈజ్, మనం ఏ రిలేషన్ వచ్చింది? మనకు లాంబ్డా ఈజ్ ఈక్వల్ టు హెచ్ బై ఎంబీ వచ్చింది. లాంబ్డా ఈజ్ ఈక్వల్ టు హెచ్ బై ఎంబీ. సో ఇక్కడ మీరు గమనించాలి స్టూడెంట్స్, లాంబ్డా ఈజ్ ఈక్వల్ టు హెచ్ బై ఎంబీలో హెచ్ అనేది ప్లాంక్స్ కాన్స్టెంట్, దాని వాల్యూ మనకు తెలుసు. మాస్ ఆఫ్ ద ఎలక్ట్రాన్ కూడా మనకు తెలుసు. వెలాసిటీ, స్పీడు, ఎలక్ట్రాన్ యొక్క స్పీడ్ కానీ లేదా ఇంకా వేరే ఏదైనా ఆబ్జెక్ట్ యొక్క స్పీడ్ కానీ ఇస్తే ఆటోమేటిక్గా మనం ఏం కనుక్కుంటాం? వేవ్ లెంత్ కనుక్కోవచ్చు. ఆ యొక్క పార్టికల్ యొక్క వేవ్ లెంత్, లేదా వేవ్ లెంత్ ఇస్తే ఏం కనుక్కోవచ్చు? స్పీడ్ కనుక్కోవచ్చు. అంటే ఉన్నటువంటి ఫ్యాక్టర్స్లో మనకు మొత్తం ఎన్ని ఫ్యాక్టర్స్ ఉన్నాయి? 1 2 3 4 ఫ్యాక్టర్స్. 4 ఫ్యాక్టర్స్లో 2 ఫ్యాక్టర్స్ మనకు ఆల్రెడీ తెలుసు ఎలక్ట్రాన్ అయితే. ఒకవేళ ఎలక్ట్రాన్ కాకపోతే ఏం చేస్తాడు? ఆ ఎగ్జామినర్ will give mass value of object and velocity of object, and he ask calculation of lambda of that object. సో అన్ని వాల్యూస్ ఇచ్చి ఏదో ఒకటి కనుక్కోమంటాడు. ఆ ప్రాబ్లమ్స్ మనం చాలా ఈజీగా చేయొచ్చు. సో విత్ దిస్ వీ completed Debroglies wave equation. Students, you remember this and practice out, copy down, try to read and write number of times, you get perfection, isn't it? Okay. Thank you one and all. Let us stop here. The remaining part we will continue in next class. Okay students, bye.